Hi everyone, we're going to show that the integral secant x dx equals ln of the absolute value of secant x plus tan x plus c. And so it's kind of like an identity. And if you start from the right side and look at that, what you can do with that is to multiply secant x times secant x plus tan x divided by secant x plus tan x. So that equals 1. And then you still have your dx. So when you do that, you're going to get the integral of secant squared x plus secant x tan x divided by secant x plus tan x dx. Now, if you let u equal secant x plus tan x, then du is you just take the derivative of each of those. So that's going to be secant x is secant x times tan x, and the derivative of tan of x is secant squared of x dx. So I'm running out of room here, so I'll just put the dx down here. So now we can substitute, and so this whole thing, the numerator equals dx, and the denominator, well, it's actually du. So let's put du, and the denominator is u. So when you integrate that, you're just going to get ln of u plus c. Then we plug back in our u, and so our final answer will be ln of secant x plus tan x absolute value plus c. Or you can go the other way. So if you're just trying to show it, we can look at this right-hand side and just take the derivative of that. So you take the derivative of the right-hand side, you're going to get 1 divided by secant x plus tan x. So we're taking the derivative of this with respect to x times the derivative of this inner portion. So the derivative of secant x is just going to be secant x tan x. And the derivative of tan x is just secant squared of x. And then we have that all over our denominator, secant x plus tan x. Now, let's factor out a secant. You factor out a secant x, you're going to get tan x plus secant x, and divide that by our denominator, which is secant x plus tan x, and these two cancel, so we get back to our left-hand side of the equation. So either way is how you would show that. That's it. Thank you. Bye-bye.